Hello, welcome to the video. In this section, we're going to be looking at 10.1, where we're going to be graphing square root functions. Now, if you guys remember from last from chapter 9, we dealt with solving quadratics using square roots. Because in order for us to solve a quadratic, we had something like x squared equals d in a general form, and then in order to take the square root of that, in order to find what x is, you had to take the square root of both sides. There were three distinct values that you could get. If d was positive, you got two answers. You got both the positive and negative value of the square root of that. If you had d was 0, you got whatever, x was going to be 0. And then if d was a negative number, you had no solution. Now, those most of those characteristics are going to be the same, including anytime that you have a negative number inside that square root, we're going to have no solution. More specifically, no real solutions. So when we're looking at graphing square root functions, we are trying to take anything that is a real value solution, okay? And then since we didn't place the square root in there, anytime that d is a positive number, we're going to take the positive value of that square root, okay? It's not going to be the plus and minus because, we put it in there, which meant that we could get, multiple values for d in order to get a result of x squared. But since that's not the case, we're only looking at the positive values when we're looking at positive square roots in this section. So what does a square root function look like on a graph? Well, it looks something kind of like this. So it has like a starting point, and then as x increases, it either is going to move upward like it does here with the square root of x, or it may move downward if there is a negative on the outside of the square root of x. The one thing that we do have to keep in mind is we have to establish what the domain and range is for these particular functions. The reason for that is because we have that stopping point, which means that there are some values for x and some values for y that we are not going to use. The reason for that is because since we can't use any negative number inside the square root, all of those values become undefined. So for the apparent square root function, my domain is going to be x is greater than or equal to 0. So if you choose a value for x, it has to be greater than or equal to 0 in order for this to hold true. You know, so what I would say is, like, if you're trying to make a table here, if x and y values. So if I say like 0, 1, 2, 3, and 4, for instance. So if I place 0 in for x, I get square root of 0 is 0. Square root of 1 is 1. Square root of 2 is about 4.41. Square root of 3 is about 1.73. And the square root of 4 is about 2. And if you notice, that is where those ordered pairs are located in this particular graph. So if you look at, oh, my graph does go through 0, 0, it does go through 0, or I'm sorry, 1 comma 1. 2 looks like it's about, 1.41. 3 looks like it's about 1.73, and 4 does cross 2. So it is consistent. So as X is getting larger, eventually so is Y. And that is how the graph is created there. And so again, that's why it has a stopping point, because if I put X as -1, for instance, it comes out as like a no solution or domain error, or whatever your calculator says for an error code. So that is where we come up with that. So essentially, if you would notice, the first two values that we place in the table are actually the values for X and Y that you're going to use for your domain range. So domain is X is greater than or equal to 0, which means it's, as X is increasing, we can get a value. Now, in this case, since, Y is getting larger in value as X is, my range is Y is greater than or equal to 0. If for some reason Y was getting smaller, it would be Y is less than. Okay. So in this particular example, what they want us to do is they want us to describe the domain of f of x equals 3 times it by the square root of x minus 5. All right. Now, there are a couple ways that you can go about doing this, but let's do it like this. So let's say I were to make our table of x comma y values. Okay. The first thing that I would like to do is the first value for x. All right. Like I just said in the previous slide, the first numbers are going to be establish what our domain and range values are. Okay. So since there's other stuff rather than x inside this square root, I want to choose a value for x that makes the inside of my square root 0. So the choice in this case, if I'm going to want to make my inside of the square root 0, what does x have to be? Well, x has to be 5. X has to be 5. And then if it were to ask you to graph, you can make values for it larger than that, like 6, 7, and 8. Because if I chose 4, 4 minus 5 is -1, I get a no solution, so I can't use that. So that is where my graph is going to start. Okay, since they're only asking us to describe the domain, and if you notice that x is getting larger, so my domain in this particular situation is x must be greater than or equal to 5. All right, now here they're asking us to graph this function, okay? So from here, again, let's make our table of x and y. All right, same rule as that I just described in the previous slide. I want to create a value for x that is going to make the inside of the square root 0. Since the only thing inside the square root is x, the only thing that logically is to make it 0. All right, then I'm just going to pick values larger than that, like 1, 2, 3, 4. Now what we're going to do is we're going to take those values and substitute them in for x and solve for y. So in this particular instance, square root of 0 is 0 plus 3 is 3. Square root of 1 is 1. 1 plus 3 is 4. Square root of 2 is 1.41 plus 3 is 4.41. Square root of 3 is 1.73. Add 3, that's 4.73. And then square root of 4 is 2. 2 plus 3 is 5. So again, if I got my graph out here, so I look at, oh, where's 0, 3, 1, 2, 3. It starts right about there. 1, 2, 3, 4. Looks like 1, 4, 2, 4.41, 3, 4.73, and 4, 5. So my graph is going to look something kind of like this. All right. Here it's asking you to describe the range. So that comes from the set of y values. Like I said, domain range comes from those first values in the table. Well, since y starts out with 3, and in this case, y increases as so does x, that means my range is going to be y is greater than or equal to 3. All right, so again, here these are situations where they want you to describe the domain in these particular equations. So again, same rules apply. So what you are going to do is you are simply just going to look at the inside of the square root and what is going to make the inside of the square root 0. So in this case, since it's only x, that means x must be greater than or equal to 0 as my domain. Okay? Here is going to be, so since it's 2x, so if I multiply by 0, so then this again is going to be x is greater than or equal to 0. All right, now for example 3, this one's a little bit different because it's a negative x attached to it. This is one of the few times where your domain is not greater than or equal to. All right, because of that negative, that means that x is going to be less than or equal to what will make the inside of that square root 0. And in this case, it will be 1. Because 1 is x, then gets negative. 1 plus 1 is 0. So that is um, the outlier in this case. If you look at the bottom with the range, basically what you're going to do is if you find the domain, or you just realize that, oh, anything on the outside that deals with addition or subtraction is going to be my range. So like here, my range is going to be y is greater than or equal to negative 4. Here, my range is going to be y is greater than or equal to 0. And here, this is y is greater than or equal to 0. And again, graphing it, please make your table and fill it in from there. If you need further explanation, please leave a comment, and I'm more than happy to graph those. So here is all of the different transformations for a square root function. All right, they give us the notation. They also give us some examples. Okay, now all this stuff can be found on page 545 in your textbook. So I would recommend you referencing that, especially when you're working on your assignments for these particular problems. What we can also keep in mind is any general square root function is going to be kind of written like this: y equals a times it by the quantity of the square root of x minus h plus k. All right, so where we can figure this out, what I'll let you know is h comma k is kind of where that starting point is on your graph. whether it goes here or whether it goes here, that's up to however the graph is presented in whatever problem. And domain and range is going to be with respect to h and k. So make sure you use h, and for range, you're using k. All right. So in this particular example, they want us to graph a negative square root of x minus 2. So again, if we make our table, what's going to make the inside of the square root 0? In this case, it's 2. All right. Oh, that's my value of h because it always appears to be the opposite of how it's presented in the problem. And k, since there's nothing on the outside addition or subtraction, should be 0. But let's take a look. If I put 2 in for x, 2 minus 2 is 0. Square root of 0 is 0. 0 minus a negative is still 0. Making values larger than 2, 3, 4, 5, and 6, I can then, all right, 3 minus 2 is 1. Square root of 1 is 1. But we got the negative, so that's negative 1. 4 minus 2 is 2. Square root of 2 is 1.41. Attach to negative, negative 1.41. 5 minus 2 is 3. Square root of 3 is 1.73. Attach to negative, negative 1.73. 6 minus 2 is 4. Square root of 4 is 2. Attach to negative, negative 2. So if I were to graph this, so I got 2, 0. Let's just say this is 2. So this is 2, 0. 3, negative 1. So my graph is going to kind of look something like this. It's asking us to compare it. Comparing this is, again, very similar to how we compared things with the quadratic. So first thing is, all right, is there any type of, you know, vertical stretch, vertical shrink? Neither. The only thing I can make a comment on is since it's negative, this thing is going to reflect over the x-axis because it's negative in comparison to square root of x. And there is a shift, which means that it moved 2 units to the right. Again, these are more examples of being able to graph these square root functions and then comparing them. If we were to look at, say, number 7 here, number 7 has a value multiplied by x inside the square root. So if you reference the chart, this is an example of a horizontal stretch or shrink. Well, since it is a fraction that is in between 0 and 1, it is actually, since it's inside the square root, it's actually the opposite of how it appears. So the description in this is actually going to be a horizontal stretch of the reciprocal of 1/4, which is 4. Okay, so keep that in mind. When it's multiplied by x inside that square root, it's whether it's a horizontal stretch or shrink, and it's always going to be the reciprocal of what it is, and if the reciprocal is greater than 1, then it's a stretch. Okay, if it was something like this, where I had h of x equaled the square root of 4x, this one here would be a horizontal shrink with a factor of 1/4 because again, it's reciprocal. And if you need help with these other ones, I'm more than happy to. Well, let's just do them. So this one here is neither a stretch nor a shrink, but it just got moved down 6 units. And then this one here reflects over the x-axis and is a vertical stretch. Okay. So in this particular one, it appears like there's a lot of transformations going on because there's a bunch of values. But again, make sure, that it's looking at this general form and just being able to look at that and say, all right, I can kind of tie that into, um, all those values and by just, referencing that chart on 545, it isn't that too bad when it comes to describing the transformation. So since A is a negative 2, you would say that, well, okay, since A is a negative 2, that means that it's going to reflect over the x-axis and that it is a vertical stretch. H in this case is 3 and K in this case is negative 2, so that means that it's going to move 3 units to the right, and it's also going to move 2 units down. All right, so if you're going to graph this, you know, I would say if you weren't planning on making a table and just kind of making a general one, I would say, okay, I'd plot the point 3, negative 2, so 1, 2, 3, negative 1, negative 2. It's right about there. And then since A is negative, that means my graph is going to kind of look something like so. And if for some reason they asked you to just to tell me what the domain and range was, this particular domain would be x is greater than or equal to 3 because it's from H, and the range is going to be y is less than or equal to negative 2 because my graph is going downward. Uh, Last one here. Again, let's just go through the transformation and graphing it. Um, if you need more help on graphing it, please leave a comment. I will certainly do so. But since A is 1/2, we have ourselves a vertical shrink because 1/2 is between 0 and 1. H in this case, remember it's the opposite of how it appears. It's negative 4. K is always how it appears, so it's positive 1. So that means there's going to be a shift in the graph. It's going to move 4 units to the left, and it will also move 1 unit up. And that is being able to graph square root functions. Hope this helps. Until next time.